Alright YouTube, I hope you're all keeping well. I'm going to start by addressing a comment from a viewer who's interested in building the magneto test stand. I did a few videos on that. Having trouble working out how to build the test gap and how to mount the electrodes. This is a very typical, from the Bendix manual, a very typical test gap. To magneto, to ground, and there's the teaser electrode. No electrical connection, do not ground. This just does something weird by being next to this electrode by helping the air ionize and start a nice stable spark. Again, I don't fully understand it, I don't think that matters, but it's there. I think if you pause the video here, you'll be able to see how to build the test gap. It says material tungsten, brass or stainless steel. Well, for me, TIG tungsten's immediately sprung to mind, and that's what I was going to use. So what we'll do is I'll just quickly show you what, if I hadn't been able to find one on eBay, what I would have done, you know, to build one fairly quickly and easily, because these are the ideas that I had. So let's have a look at it. Alright, so this is just one way that I thought of doing it if you're, I don't know how much access people have got to, you know, machinery and lathes, but if you have a drill and some bits, you can probably knock up one of these fairly quickly. If you're a time as money kind of person like we have to be sometimes, then this is probably a fairly easy way of doing it. These are some hydraulic couplings. You could also use coupling nuts. Choose a suitable size and thread. This is actually a blank. Screws into that, and this is my TIG tungsten, which is hard to do on camera, but it can go through the hole like that. The board can be drilled. One blank can be screwed up through the bottom of the board to locate this, and one blank can be screwed down through the top to lock the tungsten in position. Okay, let's just do that. Right, so there's my TIG tungsten screwed in. I can snug that down. That'll give me a little bit of scope just to adjust that as required. Another blank coming up through the bottom of the board to locate that. And I've got some wiggle and swivel room there. You're going to need, for each gap that you want to fire, you're going to need a teaser electrode, so you're going to need another one about here with the teaser electrode coming here, and another one here to form the ground. So that would be a quick and easy way to do it, and I'll just show you the one that I actually bought off eBay because it's very similar. Okay, so this is the eBay item that I bought. And you can see it has these little brass towers, the main electrode, the teaser electrode, and instead of individual grounds it's just got a solid bar. Obviously you'll need one gap like this for each cylinder that you want of the mag that you want to test. This has 6. And then we just made a little acrylic cover fit over there, and some nice little brass knobs because that was kind of fun, and stops you putting your hands on the 10,000 volt spark there accidentally, which is usually a good thing. And that was it, and I hope that helps if you're trying to build a mag tester. That's the spark gap, hopefully explained and a reasonably easy way to build it. I'll just quickly recap. The board is just Tufnell board, which you can buy online. TIG tungsten, as you can get online and sharpen up on a grinder. And as I say, if you had nothing but a hand drill, you could get some coupling nuts, which might be a bit easier than this because they have flats on them. They tend to be hexagonal. And as long as you could build yourself a little jiggy type device to make sure that you got all these heights consistent and drill through parallel, you're going to have a usable thing here, because you can rotate and position these almost infinitely. drill the holes in your board for however many cylinders you want to fire. Done job. Hope that helps. Alright, so here's tonight's little challenge. This I think is part of the suspension off a BMW motorcycle. The wheel I think goes in here. It's one of those strange German things where it's got ball joints in here. It operates more like a giant wishbone than motorcycle forks, but that's by the by. Its owner has an issue with seized in bolts. Well, this side, the head was sheared off it and it was seized in. They're actually pinch bolts that clamp this arm onto some axle bushings. We see it better from there. This one, the head was sheared off. We just welded a big blob on and wound it out. That came out, and they often respond to the heating and cooling and just give up when you do that. So, full of confidence, the other one had a head on, but it was rounded. I filled it up with weld and snapped it right off. Put another blob on, snapped that off, and I've tried 3 times and it hasn't worked. And that was mistake number 1, because while it had a head on, I had a good option of drilling it, and that's probably what I should have tried first. Alright, but that's life. So if you've got a fastener with a head on, you got a good option on drilling. Put it in the mill, center up, indicate the head. You got good options there. I've lost some of my options now. Luckily there's a spot faced area here, and it's reasonable to assume that it was drilled at 90 degrees to the split line here. So we'll set it up in the mill, see if we can't get an end mill on there, create a flat spot and start drilling. The other problem with welding first is that I've probably created some really hard and soft areas in there. It's going to try and make the drill want to wander off. But we can only try. Alright, so let's get it in the mill and see what happens. Right, here we go. Luckily this setup is not challenging. I can get a good grip on there with the device. I've trammed this jaw parallel, and I just put my angle plate on top of the vise here. I can actually get a really good eyeball on that split line being vertical there, and that's going to be good enough, I think, for this. I'll get an end mill and see if we can't create a flat spot on the end of that, what's actually now a weld blob there, and then we'll start drilling carefully and see what happens. Alright, that was extremely painless, and it gives me hope that this thing, at least for the first quarter inch, ain't going to be incredibly hard. I might do a little more to that, and then I'll get a drill, try and center up on this spot face here and go hopefully right down the middle. Bring you back in a minute. Alright, I just went in with a centre drill first. Now I'm going to come in with a decent cobalt drill. We got a new guy in the shop. He's awesome at grinding drills and a very good machinist, so better than me probably, but I'm still going to give this a go. And in fact, he's a lot better than me. He used to run a grinding section doing precision grinding, cylindrical grinding, centerless grinding, all sorts. So great addition to the workshop here. We'll just drill down this carefully again. Hope we don't hit any hard spots. The hard spot, if there is one, is going to be wherever alloy the bolt was made out of has diluted the weld metal, and they've cooled quickly or rapidly, or been quenched by this big aluminium frame and gone hard. We may hit that. That's why it's always a good idea to drill before you heat and weld if you can. As I say, I made a mistake this time. My confidence, this one come out easy with the welding trick. This one is really stuck in there. So if you get the chance to drill first, particularly if you've got a milling machine, it takes a few minutes to set up and do this. That's the way you want to go before you start welding, I think. Anyway, let's do it. That was all going so well until, yeah, maybe half to 3/4 of an inch down there we've hit something. I think actually it's the start of the threaded portion, and that fastener has took the edge off my drill. Focus, you. I'd have thought we're through the heat affected zone by now. It's just a very hard, strong fastener. I'm going to sharpen this drill again, use some cutting oil and slow it down, just see if we can't get, I don't know, as far again. And we'll consider the options, easy out or drill all the way and pick up the threads. Alright, I'll bring you back in a second. Alright, we went carefully that time. I think another 1/4 inch and we'd be down to the depth of the old fastener that was in the other side. So that's what I'm going to do. And then I've got a couple options. One is to drill a clearance hole through this top here, the full diameter of the fastener, and try and extract the threaded part, maybe with a sleazy out or something like that, and lots of heat. And then if the threaded part doesn't come out, we've got the option to carefully keep drilling and picking and tapping and generally hoping that we can shift it. So we'll just go a little bit deeper and then we'll have a bit of time just to consider where we go. Alright, we got through it and I felt my drill break through the bottom into a little void before the soft alley, so that's very encouraging. I think I am going to get a clearance drill, and try and take the shank of this out to here just by pecking away at it. I hope it doesn't go off centre. I think if I peck carefully it'll be okay. Alright, luckily I've got the other side for reference. I've selected a suitable drill for clearancing. We'll pop that in there and we'll really carefully peck away at those that shank and the weldy blob and see what happens. By the way, this part from BMW is many thousands of pounds, and I'm told by the owner that even a second-hand one on eBay is going to set him back over $1,000, and that may be no better than this one. So I'm trying quite hard not to fuck it up. You know, I'm confident we can do something with it. I mean, even there's quite a lot of meat around here. Even if we had to oversize it, helical the bottom and put a bush in here, it would be doable. So I'm going to persevere. into a bit of an issue there with the drill deflecting upwards and trying to get into the alley. So I'm going to soak this in some goop overnight and have a thorough look at it in the morning out of the mill in the daylight. It's fairly easy to get the setup back again. Just see where we go, and sometimes it's best to have a pause and come back for part 2. Thanks for watching. Good night. Yeah, we're not doing too badly, but that drill is going to walk into the alley when it hits some hard spots and things. I'm going to come back in tomorrow when I'm not tired with this little stubby end mill. I know there's a hard spot in there. It's probably worth sacrificing the odd end mill to make very sure that we don't walk into the aluminum and screw it up, because it's one of those parts. It's worth spending an extra little bit of time for the value of the part and the fact that it's difficult to replace. So I am going to go home now and get some sleep and worry about it another day. Thanks for watching. Right, much as I wanted to get home, kind of couldn't leave that, so I started with my little end mill. It's actually corrosion on that there. Carefully focus you, nibbling away at it. It's hard to see, but it's working. I'm not cutting the alley away. I'm getting rid of that shank. Left a tiny bit of steel at the top there, I think, but so far so good. Going to persevere with that carefully till I get to the split line at least, and then pick out the bits of steel and see where we go with the threaded part. Good night. This really is good night. Cheers.